I'm going to solve as many dynamic programming problems as I can. And from the very beginning, I want to just state that I'm not going to cover any theoretical concept regarding dynamic programming. Because I think that is a bit daunting at the very beginning to understand all those concepts of overlapping subproblems and optimal substructure. So we will get to those points when we will require them. Till then, we will just think dynamic programming problems as a recursion problem, and we will just use recursion and nothing else. So to state what recursion is, it's just calling a method from inside that method, and it will keep calling the same method. So there should be a base condition which will break the this recursion. So we will get to that base condition. uh, Basically we need to find in all the problems we need to find that base condition. And one very important thing that comes in dynamic programming problems is state, defining of a state. So what is state? State is nothing but a set of variables which defines a particular scenario. That's it, which defines a particular scenario. What do you mean by scenario? So first thing, so here in dynamic programming problems, we will think scenario as any variables which is going to help us in finding the solution. Basically, if something is not relevant, it should not be considered as a particular state. So we will come to this state practical. So what for each of the problem, I will define the state, and I will try to try to solve all those problems through recursion. So let's just get started and solve our first dynamic programming problem, which is very standard problem of dynamic programming called Fibonacci number. Basically has this we have been given the first two elements, 0 and 1, and and we need to find the nth Fibonacci number, and which is the sum of the two previous Fibonacci numbers. And so we will be given n, so we have to return the nth Fibonacci number. Let's just think. So the problem itself states it's a recursion problem, right? Because if we have a method, how do we find nth Fibonacci number? We need to find first the n minus 1th Fibonacci number and n minus 2th Fibonacci number, and then we will add it. So itself it is clearly stating that it's recursion. So let's just have a recursion. We will have a recursion for this. Now defining of a state. So what does state means here? What we need to know uh, to find a particular Fibonacci number, the nth, right? The n, the value of n. We need to know what is the value of n. So that's more than enough to know what will give us Fibonacci number. So let's say we have a function. Let's say we have this recurrence recursion function in which I will be given, let's say, k, and k is defining our state. So I just need to know at which state I am, at which kth Fibonacci number should be returned. So what will be my recursion? What will be the recurrence formula? Or would I would say? So recursion that would be just I will return what for to know the kth Fibonacci number. We need to know the k minus 1th, and we need to know k minus 2th. That's it, right? But this will keep decreasing. We need to put a base condition here to stop this recursion. So just taking from the problem, if k is 0, just I will return 0, and if k is 1, I will just return 1, right? And that's it. That our whole recursion function is complete. Now I have to just call it. So just call this function, and it will return. It should return me the correct uh, recursion, the correct Fibonacci number, nth Fibonacci number. Yes. So let's try to solve for bigger numbers. Let's try to solve for 10, right? Oh, it is coming. So see, we can see n can be 30. Let's solve for 30. What it is returning? Let's see. Let's see. So it should take time a bit but it is returning well, right? Let's try to submit it, whether it works or not. Oh, it works and it is faster than 27%. I don't know how, but it is not taking any memory because I am not saving anything, right? In memory means we are just means runtime we are saving stack for recursion, but apart from it we are not saving anything. That's why our memory consumption is very low. But time can be improved. Let's see what we can do. Now here comes the dynamic programming thinking. We need to find k minus 1th and k minus 2th. Let's say for 3, if n is 3, let's say if my n is 3, then I will call the recurrence for 2 and recurrence for 1, right? Now recurrence for 2 will call recurrence of 1 and recurrence of 0, right? And recurrence of 1 will just return, right? In simple 3 I am I am calling the 1 twice, right? What we can do, this is the basically crux, or I would say the main difference that comes in dynamic programming is we are solving the same problem many times, right? For value n equals to 1, we are solving it twice. Why should we solve it twice, right? We can just save it in memory. If we know the answer, we will save it so that later we will use it. That's it. This is dynamic programming. Now what I will do, I will just memorize it. This is called memorization also. uh, so how will we save it? So let's say since there is n, I will have a, let's say, vector in which I will, let's call it dp, dynamic programming, just for dp, and I will initialize it with vector and plus 1 and each value as minus 1. Now, so in this one, I will try to solve for each of the value the solutions for their that position basically. So it means dp0 will have the 0th, dp1 will have the Fibonacci number 1, and so on. So let's keep the base condition as it is. Now what I will do, I will just put if I don't know the answer yet, or sorry, let's just think reverse. If I know the answer, so it means if I know ki it's not minus 1, I will just return it. It means I have already solved it. Now, what I will do, I will just do this. I will save it in kth because this is kth Fibonacci number, and then I will return. That's it. So if I know the answer, I will return it. If I don't know answer, I will go and find it. That's it. Let's see if it solves all the problem. Let's try to submit again. And yeah, see, it's faster than 100%, means it is taking very much less time. Obviously we are taking space, and we will say we are saving some variables in the memory. So means we are saving a vector of whole size, and so it is taking some memory, and it will take memory. Obviously, see, I am not saying this is the most optimal way of solving it, but I want to end the solution here only because this will give me the correct way to proceed further in future problems. I can go. So what I want to say, this is what in dynamic programming concept, if we say, this is called uh, top to down approach, right? Top to down means we started from n and we kept going solving for the smaller problems and all. We and This is top down approach, and I want to solve it all the problems top down approach only because first it needs just recursion and we and saving the solutions basically. So the third concept that we learned is this is top down approach. So it's recursion. Top down is nothing but recursion plus memoization. Yes, saving the solutions of already problems is memoization. Nothing else. So I will be going to solve all the problems through it. So thank you, and see you in the next problems. So